In this video, what we're going to do is learn how to plot data. So basically, it's make easy things easier and make hard things possible. So first of all, before we actually plot the data, we actually need to know some terminology. So first of all, what is the figure? So for a full figure, it's actually the canvas. We will have a canvas just like your paint area. Everywhere you can paint on the canvas, right? And then we're going to have the axes. We normally have X and a Y axis. So you're going to have axis right here. You're going to have X label and a Y label right here. And then, so this is your axis and this is your Y axis. And those are the value of the axis, x-axis. Those are the y-axis. And in the middle is actually the whatever is plot. In this case, is just a default blue line, right? And then you have the title. Sometimes you may have legend. It's a small box. It's showing you what those legend is, right? So those are the basic concepts. So when we're using the plot, we're going to first, let me first clean out all the output, and then we get started from the scratch. And first of all, we're going to import a module. It's called the MatPlotLib .pyplot. So this is going to be the one that we use to plot things. And as a PLT, that means we're going to plot as a plot. And the first one is actually import those data, and then we're going to actually create. There are actually tons of functions, probably hundreds of the functions to allow you to plot sophisticated figures. And here we're going to learn some basics. The plot, for example, I have the x value is 0, 1, 2, 3, and the y value is 0, 1, 2, 3. This is 1, 9. And I am going to use this as a dash, as a B. B means it's blue line. And then I have another x and a y. And then it's going to be a dash dash is a red line. So one is blue, one is red. So I put my X label and a Y label, and then I can plot dot show. So this is actually it's gonna plot this for us. So we will see what this dash dash means. This is the dash dash, and then this is a regular 9. So you see X and Y, and that's the range of the value, and that's the X's value. Okay. So this is a simplest way. So normally when you plot, you definitely will use a plot, and then X and Y label. It's not necessary, but the plot is mandatory. Show is normally is mandatory. But for notebooks, you don't need to use the show. It will show anyway. However, it's always good habit to have the show, because if you are using the script way, you will have to use the show, otherwise it would not show it to you. So we have X and Y, okay? And then so we have X and Y and plotted. So in this case we have 2 9s, but a lot of times you may only have 1. You don't even need this part. So let's take a look at another example. Keep in mind, MatPlotLib is stateful. That means you start to plot one thing, it's actually built on top of the previous one. So suppose we build one as a label. So I only have the X value, I only have the Y value, and then it will give you 1 and 2. So I show the legend, and then has the show. So you will see my values. So I have 0, 1, 2, 3, 4. So I have totally 5 elements. If I don't specify X, it will use the default from 0 to 4, use the index, and then that will be my y's value. So apparently you will notice that this is the it's double, right? This 2 is actually double the 1's value, and you see the default is actually blue 9s, and for all the others this means a triangle, and then dash, triangle dash, that's why triangle dash, and the shape, this is the shape, okay. And the color, normally it will increase by 1 from the previous color. So this is how do we do. And this one, you just print out this legend, print out this label. So it's actually stateful, so it's built on top of the previous plot. So if I comment this out, for example, if I comment this out and then I plot it again, you will notice I only build 1 9. So I actually make another one, make another plot. So it's actually built on top of the previous blue one. I can add more elements to it. Okay. However, plot, once you plot it, and you will have to plot another one to be able to show. It does not show anything since it haven't created another plot yet. So the clause will to finish a plot is simply just plot.close. Format coding. Format coding, this is just a small portion of the format coding. It's actually, the real ones is a lot more codes than this one. So you can briefly take a look. The dot means point. The underscore means horizontal lines. This is bar means vertical lines, and you can have plus, hexagon, all of those shape. Actually, way more than what you think. And you can have others. You can have other colors. And here is basically, this is the style. This is the 9 width, and so on, right? So we are plotting this curve. You will see it becomes O. This becomes O because it's blue, and it's 0, right? O, it's a circle. That's what we showed here. It's circle. Okay. Another one is the plot expression data. Suppose I have a Spellman data. The Spellman data is looking like I actually obtained this data from another university, and it's called a Spellman, and it's about the gene sequence, right? Gene values at different times. So I can read the file into, I can read the CSV file in, and then I can get the header part and I get the data. If you want to see what's the data look like, I can show it to you. It's gonna be under Spellman. It's actually Excel files. The data will look like this. You will have on the top, you have the time, and then it's 40, 50, and a lot of times. On this column is basically the gene, the label, the different definition of the gene. It has probably over 4,000, and then for each time it has a value. So this is the data look like. What we did is in this program, we simply first read the header part. So we just read 19, and that will be our header. We strip and split by the comma, because that's the separator. And then we have the data. Then we read the whole file 9 by 9, and then append it to the data in a list. And then we are actually reading. Suppose we only read the first 10 rows, the first 10 columns. I'm sorry, the first 10 columns, all the rows of the first 10 columns. And first 10 values, I put that way. So the values will be in here. We actually are having all those values as a float, and here we map integer of the header as a time, right? So that would be times, and here is just the rows for all the values, and then we put them in a list. So values are list of floating numbers, times are integer of time value. Then we can plot them, and the label is actually the gene's name, and then we can actually start to plot it. So for each of those we plot it. So there's gonna have a lot of lines, right? As 10 lines. So if you run this, you're gonna see 10 lines. Okay, different lines. See, I don't need to specify the color. It will differentiate automatically by the color. And then another example is I can actually start to read all the data together. I can read all the data and then make an array like that, and then I can start to build other type of figures. So in this example, yeah, that's just the processed other data. This bar chart, we can make a bar chart too. The bar chart will be like this is X, this is Y, X, and Y. So I place two bar chart together. So that will give me different colors. And then alpha equals to 5, label is 1, 2. So when you run this, you're going to see those values. And then X ticks will be ABC, the X ticks ABC, right? And then so we have the value, only 3 values, so I can label them as X, Y, Z. And then then I can have the limit, Y's limit as 0 to 100. So 0 to 100. Otherwise, it may only show you like right here. It may only show you that right here. And then I can print out the legend right here. For histogram, I can generate some random numbers. So this is a normal varied number between 0 to 1, and then this becomes 1,000 random numbers. That will be in a random number list, and I can simply just plot the histogram, and you're gonna see this is gonna be the histogram. So that's the histogram. Okay, and then here is the combine the charts. Suppose this is the histogram, and then I want to do the another line. I can plot X and Y, and then into as a red line, and the line width is number 3. Then I can show combine these two together. So you see this is a combination of the two. Then I can do subplot as n rows and columns. So suppose I have a plot subplot 2, 1, and then I have the set the current axis as the first one, and then I plot the header and the data. So this is my X, this is my Y, and then this is basically give the floating number of those values. So this is just the very first one, right? And this is gonna be actually the second one. We're starting from 0, right? So plot Y label, that will be Y's label. So if you show this one, you're gonna see two figures. So this is the fig and axis. Okay, So if you run this, you're going to see two of those figures. So this is the one of those. This is the second figure. So this is data. Data totally you have, this is the first row, this is second row, and this is all the data from the, not from 0, because 0, that's the gene's name. That's gene's name. And the header is basically the time. Gene, you don't, for the header, the 0 is actually the word time. And from the first one, starting as a 40 to all the way to the end. So that's how the date x and y. And here you will see that actually has the subplot 2 by 1, 2 rows, 1 columns. So fig and axis here specify x axis 0, axis 1. We can do more. Suppose in this subplot, I can add another one. I can do another one to add multiple plots on a figure. So for the subplot, number of genes, that would be 3 by 1. So that would be 1, 2, 3 figures vertically. And then share all the x's and share the y. So let's say x and y are also shared. And then I have the figure and the axis. So here, when I plot, I will see axis I. So I have a range. So the range will be 0, 1, 2. Because the number of genes is 3, then that's in a range. So 0, 1, 2. Dot plot, the header. So I actually get the data accordingly. And the color is actually in a list of the colors, so it's changing too. And then I set the white label accordingly too. So when I run this, you're going to see 3 vertical figures. And I can explore in the charts. For the charts, I can do pie chart, right? We can do pie chart. Instead of we use the plot.show in this example, we want to save it. We can save the figure. So that will be a permanent figure. And then I can, same thing, I have the axis. And then I plot the pi, so this is my value. And then I have the labels. So that will be 3 labels. And then I save the figure. It will also show it right here because the pi is actually showing it. We said we don't need to show, right? So that will be the pie chart. And if you want to check if this is in the folder, you're going to notice that this is it is actually down there in the directory. That's the pie chart. We have the pie chart, and that's the size of the pie chart. Other chart types, you can actually check the examples. It's going to show you lots of MatPlotLib. It's a lot of beautiful and fancy plot, and you can see for each of them you actually can see the data, can see the results. How do they do? For example, this is the one, and that's a script code, and you can always go back and check the results. Okay. So come back here. If just in case, sometimes you may say, "Oh, I have very, very complex data. I want to display them." Then you can use another one. It's called Seaborn. Seaborn is make some hard things easier. Again, there's are lots of libraries too. You see, many of those are very, very fancy and very, very sometimes it's hard to display. Like those, right? Like those. It's very, very powerful tools, but we're going to just use the simple stuff. And the next one is going to be our part of our project. I'm going to or assignments. Let's first make it as assignment. We will plot the gene, plot the histogram, plot the final expression, and plot the histogram, and many of those things. So I actually will solve it with you, and I actually posted my solution right here. For example, for the question 1, plot a gene. We first get the gene, and we prepare the gene. We get the first row, like plot the initial expression level, plot the final expression. So we get the first, we get the plot the gene, and we plot the first. This is this, and then plot the last, and then we plot the histogram, and we have the histogram right here, and when we can do all the others. The last part is actually not needed right now. It's just an example that I show we can do more things. We can plot the stock price as well. So that's all about it. So this is it for this lab.